So let's start with the problems on surface area and volumes. The first exercise, first question. Two cubes, each of volume 64 centimeter cube, are joined end to end. Find the surface area of the resulting cuboid. Okay. So we have got two cubes. Okay. Volume of each cube is 64 centimeter cube. So the given part is volume of the cube. Volume of cube is given as 64 centimeter cube, and we have to find the surface area of the resulting cuboid. Okay, now first let's draw the figure. We have got two cubes. Okay, let me finish the diagram. Yeah, so as you can see, we have combined two cubes, and the resulting figure that we have got is a cuboid, isn't it? So let's say the edge length is a. Okay, obviously in a cube all the edges will be of same length, right? So this is another cube, the edge length is a. Okay, so this will also be a, and the height will also be here. Okay, now in the resulting cuboid, if you observe, the length has become 2a, and the breadth is a itself, and the height is also a itself, isn't it? In the resulting cuboid, the length is 2a, the breadth is a itself, and the height is a itself. Now what is a? A is the edge length of the cube. Okay, so let's find that first. Okay, so volume of cube is given as 64 centimeter cube, and we know that volume of cube is given by a cube. So a cube is equal to 64. Therefore, a will become cube root of 64. Okay, what is cube root of 64? It is 4. So a value is 4 centimeters, which implies L will become 2 times a, that is 8 centimeter. Breadth is 4 centimeter, and height is also 4 centimeter. And here we have to find the surface area. Obviously it will be total surface area because all the faces are closed. Okay, so TSA of cuboid, TSA of cuboid is given by the formula 2 times LB plus BH plus HL. Now let's substitute the values. 2 times L into B, that is 8 into 4, then 4 into 4, then 4 into 8, isn't it? We have just substituted the values. So 2 times 8 fours are 32, 4 fours are 16, again 4 eights are 32. So we get here 2 times 32 plus 32, 64, 64 plus 16 is 80. So 2 into 80 is 160 centimeter square. So that's the resulting surface area of the cuboid. Okay. So let's get into the next question. A vessel is in the form of a hollow hemisphere mounted by a hollow cylinder. Okay, so what we have got is a hollow hemisphere, something like this. Okay, let's say this is an hollow hemisphere. Okay, on top of this, we have got a hemisphere mounted something like this. Sorry, on top of this, we have got a cylinder. Okay, this is the shape of the vessel. The bottom one here, actually it is a sphere. On top of it, we have placed a hemisphere. Okay, something like this. Obviously this won't be visible. Okay, just for our reference, just to show that here we have got a hemisphere and cylinder. Okay, now the diameter of the hemisphere is 14 centimeter. So diameter of hemisphere is 14 centimeter, which implies the radius, let's take it as r, that will be 7 centimeter. If you observe the figure carefully, the radius of the cylinder and the radius of the hemisphere will be same because both the bases are coinciding. If you observe here, they are coinciding, isn't it? Therefore, it will be same. The radius of cylinder and radius of hemisphere will be same. So let's take it as R itself, 7 centimeter. And the total height of the vessel is 13 centimeter. So that's the total height from the top to the bottom, okay, which is 13 centimeter. Okay. Now find the inner surface area of the vessel. Okay. Now this is like a glass tumbler, isn't it? Now what is the inner surface that you can see? You can see the CSA of cylinder and you can see the CS of hemisphere. That is all we can see, isn't it? Therefore, the required area or the inner surface area of vessel, inner surface area of vessel will be equal to CSA of cylinder plus CSA of hemisphere. Now CSA of cylinder is given by the formula 2 pi RH and CSA of hemisphere is given by the formula 2 pi R square. Now remember, before substituting the values, we must take common. So here 2 pi R is common, H plus R is left out. So now let's substitute it. 2 pi is 22 by 7, R is 7, but we don't know the value of H, isn't it? So what is H? Height of the cylinder. Height of the cylinder is from this point, from the center of the top base, top part, top circular part to the bottom. Okay, this value is H. Do not take 13 centimeter as H. Okay, that 13 centimeter is the total height of the vessel. Okay, so here H is only the cylindrical height. How do we find this? It's very easy. From the center to any point on the hemisphere is what? Radius, isn't it? So this radius is 7 centimeter. Okay, so the total value is 13. In that, if you from this top to this bottom is 13. So in that 13, if you subtract 7, we get height, isn't it? So height is equal to 13 minus 7. Therefore, H is equal to 6 centimeters. Height is equal to 6 centimeters. So H is 6, R is 7. Okay. So let's simplify it. 2 into 22 by 7 into 7 into 13. 7 gets cancelled. So we are left with 2 into 22 into 13. So 2 into 22 is 44. 44 into 13. So we get 572. Okay. So the answer will be 572 centimeters square. That's the required area. Let's get into the next question. A cone of radius 3.5 centimeter mounted on a hemisphere of same radius. So we have got a toy which is in the form of a cone mounted on a hemisphere. That is, we have got a cone. Let's say this is the cone. Okay. Which is mounted, that is, it is on the top of an hemisphere. The toy looks something like this. Okay. Now the radius of the cone and the radius of the hemisphere are obviously same because they coincide with each other. So R is equal to 3.5 centimeter. Again, the total height of the toy is given. The total height of the toy, that is from top to the bottom. Total height is given as 15.5 centimeters. Okay. Now again, obviously we need the height of the cone. Okay. So from here to here, it is radius, which is 3.5. Okay. In 15.5, if you subtract 3.5, you get the height of the cone, isn't it? So H will be equal to 15.5 minus 3.5. Therefore, H is 12 centimeter. Okay. We have to find the total surface area of the toy. Okay. Here we have to find TSA of toy, total surface area. Total surface area of toy will be equal to, you have to be very careful. Just because they have used this word total surface area in the question, it is not like that we have to take TSA of cone and TSA of hemisphere. That is wrong. Okay, we are not supposed to do like that. Okay, here total surface area. Why the word total surface area is used? Because it is a combination of two different figures, right? Cone and a hemisphere. That is why they have used the total surface area. Please do not get confused. Now what we have to do is we have to look at the toy and uh, check out the visible surfaces. The surface that is visible for us is the curved part of the cone is visible and the curved part of the hemisphere is visible. Is there anything else visible? Just imagine this. Okay, this kind of a toy. You can observe only CSA of cone and you can see CSA of hemisphere, isn't it? Now CSA of cone is given by pi RL. CSA of cone is given by pi RL and CSA of hemisphere is 2 pi R square. We have to take common. Pi R is common. So L plus 2R will be left out. Now, as you can see in the question, the value of L is not given. Okay, so we have to find L. How do we find it? We have got a formula to find L. L is equal to square root of h square plus r square. So h is 12. So 12 square plus r is 3.5 square. So 12 square is 144 and 3.5 square is 12.25. Find 35 square and place the decimal. Okay, so this becomes 156.25. So in the next line, L is equal to square root of 156.25. So here what we can do is L is equal to convert it into fraction. It will become square root of 15625 divided by 100. Find the square root of 15625 by prime factorization method. I hope you guys know it. Or let me do it and show you. 5 3s are 15, 5 1s are 5, 5 2s are 10, 5 5s are 25, 5 6s are 30, 5 2s are 10, 5 5s are 25. Again, 5 1s are 5, 5 2s are 10, 5 5s are 5, 25s are 5, 5s are 5, 1s are. Okay. Now start making pair. This is a pair, this is a pair, and this is a pair. From each pair, we have to take one number. So 5, 5, 5. From this pair 1, from this pair 1, from this pair 1. And multiply all those numbers. 5 into 5 into 5 is 125. So therefore, square root of 15625 is 125. In the denominator, it is square root of 100, which is 10. So 125 by 10 is 12.5. So that will be the value of L. So we have to find the square root using prime factorization method. Then we'll substitute now. Okay, we got the value of L. Okay, the pi value is 22 by 7. R is 3.5. Okay, so L is 12.5 plus 2 into R is 3.5. So let's simplify this. 22 by 7 into 3.5. 12.5 as it is. 2 into 3.5 is 7. Okay. So here very clearly 3.5 ones are. If you double 3.5, you will get 7, right? 3.5 ones are, 3.5 twos are, 2 ones are, 2 11s are. So therefore it becomes 11 into 12.5 plus 7 is 19.5. Okay. And if you multiply it, you get 5, 4, and carry 8, 9. 1945. Let's check it out. 195, 195. Okay, 5 as it is, 14, 11. Okay, 2145. 2145. Okay. So many centimeter square. Let's get into the next one. A cubical block of side 7 centimeter is surmounted by a hemisphere. Okay. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. Here, let's try to draw the figure. Okay. What we have got is a cubical block. Okay. That is a cube. On top of this, we have placed a hemisphere. Okay, first let's try to draw a cube. Okay, so let's take a square. Let's make use of this. Okay, so let's complete it. Okay, so we have got a cube. On top of this cube, we are placing a hemisphere. What is the greatest diameter the hemisphere can have? Okay, the hemisphere, see, let's say this is the base. Okay, and the hemisphere looks something like this. Okay, the figure seems not to be so perfect, but I hope you guys can understand. So this is how the hemisphere looks like. Okay, let me paste a figure which is in the example problem, a similar type. Okay, now if you observe, this is a different question. Okay, so don't worry about the dimensions. Okay, forget about the dimensions given. Okay, so I just wanted to say how the figure looks. So this is how the figure looks. Okay, now the greatest diameter that can be drawn will be this one, right? Let's say this is the diameter, and this diameter will be greatest, and it will be equal to this edge length, isn't it? Very clearly, the greatest diameter will be equal to edge length. What is the edge length given? It is given as 7 centimeter. So the greatest diameter that the hemisphere can have is 7 centimeter, and we have to find the surface area of the solid. Okay, now let's keep this figure as it is. Okay, let's discard this figure which I have drawn. Okay, let's take this figure, and remember the dimensions are different. Okay, only for our understanding we have kept this figure. For time being, let's cancel this dimensions. Okay, instead of that we'll take 7 centimeter. What is the diameter? It is given as 7 centimeter, and this here also the edge length is 7 centimeter. Even here the edge length is 7 centimeter, and here it is 7 centimeter. Okay, now so we got to know that the diameter, the maximum diameter is 7 centimeter, which implies the radius will be equal to 7 by 2 centimeter. Now we have to find the surface area. Okay, now what we have to do is we have to find all those surfaces that are visible to us. Now very clearly this curved part, okay, this curved part of the hemisphere, it is visible to us, isn't it? So let's use that CSA of hemisphere. Let's take that. Okay, now what we'll do is let's find the TSA of the cube. Okay, TSA of cube. When I say TSA of cube, okay, let me push this a little bit that side. I'm sorry. Yeah, TSA of cube. Remember when we said TSA of a cube, it is all the 4 walls and the base and the top, isn't it? 1, 2, bottom, and this side, okay, and that side and the top. All the 6 faces comes. Okay, so TSA of cube. But if you observe very carefully, wherever this hemisphere is placed, this part which I'm shading, okay, this part, okay, where the hemisphere is placed, this exact part is not visible to us, isn't it? But we have taken TSA of cube. If I say TSA of cube, this area which is not visible to us, that is also considered. But we are not supposed to consider that, right? Let me draw the top view. See, let's say this is the top view of the cube. Okay, on top of this we have got an hemisphere. Okay, now this is how the hemisphere, the circular part, this circular region is not visible to us. Only this edge part here and here and here and here, these are visible to us, isn't it? So we are not supposed to find this circular part. We don't want that because it is not visible to us. Therefore, how do I find it? Very simple. Okay, now simple thing is, this circular part, we don't want it, but we have included in this, isn't it? While finding TSA, this is also found. Okay, but I don't want this. So what is the shape of this? It's a circle. So if I don't want it, I'll just subtract it. Okay, so minus base area of hemisphere. That's it. Okay, what is CSA of hemisphere given by 2 pi r square, isn't it? Plus TSA of a cube is a cube minus base area. Base is a circle shape, so it is pi r square. So 2 pi r square minus pi r square. Okay, 2 pi r square minus pi r square gives you pi r square plus a cube. So what is the value of pi? It is 22 by 7 and radius is 7 by 2. Okay, 7 by 2 the whole square plus a cube. A cube is 7 cube. Okay, so let's find this. 22 by 7 as it is, 7 by 2 the whole square is 49 by 4 plus 7 cube. Okay, 7 into 7 into 7. Okay, we get how much? 343, isn't it? Now here you can cancel 7 ones are 7 sevens are 2 twos are 2 11s are, so it becomes 77 by 2 plus 343. So 77 by 2 is around 38.5. Okay, so 38.5 plus 343, so that will be equal to let's add it, 343.00, 38.50. So 8311, 1 carry, 437 plus 1 8, 381.50. So the total area comes out to be 381.50 centimeter square. Okay, so if you observe, we found the TSA of the cube, but we require only this regions, okay, which is visible to us. Okay, but this region is not visible, but we have found it. So to eliminate it, we are going to subtract it from the base area. Okay, so the fifth question is exactly the same type. Okay, now instead of keeping a hemisphere on the top, what they have done is they have carved a hemispherical depression. Okay, that will be, it'll be in the bottom side. Okay, now the same type, in says suppose the hemisphere is on the top. Now instead of on the top, it is like carved. Let's take a cube. Okay, let's say this is a cube. Now here we have carved, that is we have scooped some amount of cube from it, and this is looking like a cubical, hemispherical shape. Okay, that is the figure. Now here you can observe the same formula. Okay, because in the top part of the cube, here we have carved a hemispherical, isn't it? So this region, okay, it is not there. Okay, there is nothing here, it is open. Okay, but when you say TSA, we have found this, so this is not there. So what we have to do is we have to subtract it. Again, the same formula, if you use the same formula, you will get it. And instead of 7 centimeter, they have given it as L. Okay, so the diameter was L. In the previous case, the diameter was 7 centimeter. The same type of problem, so you can try it out. Let's get into the next question. A medicine capsule is in the shape of a cylinder with 2 hemispheres stuck to each of its end. The length of the entire capsule is 14 mm. The diameter is of the capsule is 5 mm. So diameter D is equal to 5 mm. Okay, find its surface area. Now this part is an hemisphere, and here also you got an hemisphere. Okay, so what are the surfaces that are visible to us? the CSA of this side, CSA of hemisphere, CSA of hemisphere, and CSA of cylinder. Okay. Therefore, the required area, let me write it here, required area is equal to 2 times CSA of hemisphere, because both there are two hemispheres, okay, and CSA of cylinder. Now, the radius will become 5 by 2 mm. Okay, that is 2.5. The radius of the hemisphere and the radius of the cylinder are same. So let's take a same r. So 2 times CSA of hemisphere is 2 pi r square plus, and CSA of cylinder is 2 pi rh. So here you can take 2 pi r as common. Left out thing is 2r plus h. Okay. Now what is h? Height of the cylinder. The height of the cylinder is actually from here to here. Okay, that's the h. Now how do we find h? Very simple. From here to here it is known as radius, which is 2.5, and here also you got 2.5. Okay, so the total length, okay, that is 2.5 from the left hand side plus the height of the cylinder plus 2.5, that will be equal to 14, isn't it? So that is this length 2.5 plus this length h and plus this length 2.5, everything will give you 14. So 2.5 plus 2.5 is 5. So h plus 5 is equal to 14. Therefore h is 14 minus 5, which is 9. Okay, so that is height is 9 mm. Let's substitute in the formula 2 as it is. Pi value is 22 by 7. R value is 5 by 2 into 2r. 2 into 5 by 2 plus h value is 9. Okay. So let's simplify this. So this 2 and this 2 gets cancelled. 22 by 7 into 5. This 2 and this 2 gets cancelled. 5 plus 9 is 14. So 7 ones are 7 twos are. So 5 twos are is 10. 10 into 22 is 220. Therefore, it becomes 220 millimeter square. That's the required area. Tent is in the shape of a cylinder surmounted by a conical top. If the height and the diameter of the cylindrical part are 2.1 and 4 meter respectively, and the slant height of the top is 2.8 meter, find the area of the canvas used for making the tent. Also find the cost of the canvas or the tent at the rate of rupees 500 per meter square. Now, what we have got as a tent, obviously you guys know the shape of the tent. The bottom part will be a cylindrical shape. On top of this, we have got a conical shape. Okay, it is also mentioned in the question. Okay, so the cone and the bottom is cylinder. I've just drawn a rough diagram. Okay, the height and the diameter of the cylindrical part are 2.1 and 4 meter. That is the height of the cylinder. Let me take it as HCY. Okay, HCY represent the height of the cylinder, which is 2.1 meter, and the diameter of the cylinder. Here the diameter of the cylinder and the diameter of the cone are same. So let's take D itself. Let's not take it as DCY. Okay, diameter of cylinder and diameter of cone, two different things is not required. If diameter is 4 meter, implies radius will become 2 meter. Now the slant height of the cone is given. The slant height of the cone is 2.8 meter. Okay. Now what we have to do is we have to find the area of the canvas used for making the tent. To make this kind of a tent, obviously we would have used to form the conical curved part, isn't it? We would have used the canvas for the curved part of cone and for the curved part of cylinder. That's it. In the bottom, it is always the ground, right? Here we don't cover with canvas, isn't it? Therefore, the required area, okay, area of the canvas used, area of the canvas used, that will be equal to CSA of cone plus CSA of cylinder, isn't it? So CSA of cone is what? Pi r L, and CSA of cylinder is what? 2 pi r HCY. Okay, let's take it as h itself. Any of the, we are not going to use height of the cone. Let's take it as h itself. So what is common here? Pi r is common. So you are left with L plus 2h. Okay. On multiplying back, you have to get the previous one. Okay. Pi value is 22/7. R is given as 2. L is the slant height, which is 2.8 plus 2. And h is the height of the cylinder, which is 2.1. So let's simplify this. 22/7 into 2. 2.8. 2 into 2.1 is 4.2. So 4.2 plus 2.8 is 7 actually. So 22/7 into 2 into 7. Okay, 7 gets cancelled. Therefore, the area will be 44. 22 into 2 is 44 meter square. Okay. So then we have to find the cost. For 1 meter square, it is 500 rupees. So what they have given is rupees 500 per meter square. So for 1 meter square of the cloth, we have to pay 500 rupees. Now, what is the total area of the canvas used? 44 meter square. So total cost is equal to area of the canvas multiplied by cost per meter square. Area of the canvas is 44 meter square and cost per meter square is 500. Okay, so which comes out around 22,000. Okay, rupees 22,000. So that will be the answer. We have found the area and we have found the total cost also. Let's get into the next question. From a solid cylinder whose height is 2.4 centimeter and 1.4 centimeter, a conical cavity of same height and same diameter is hollowed out. Find the total surface area of the remaining solid to the nearest centimeter square. So what they have given us is, we have got a solid cylinder. When we say a solid cylinder, it is completely closed. Okay. Say suppose we have constructed a cylinder, a cylindrical shape using a wood. Okay. It is completely closed, isn't it? The best example is the pillar of a house, circular pillar. Okay. This can be a solid cylinder. Okay, because the top is closed, bottom is closed. Okay, inside also we have got materials, isn't it? It is not hollow. Okay, so this is a solid cylinder. In this kind of a solid cylinder, what we are going to do is, on one top of the cylinder, we are going to do some carvings. That is, we are going to carve out a shape that is in the shape of a cone. Okay, we have created a conical cavity of the same diameter and of the same height. Okay, that's how we have drawn the figure like this. Okay, now what we have to find is the total surface area of the remaining solid. Okay, now what are the things given? The height is given as 2.4 centimeter. The height of the cone and the height of the cylinder are same, so let's take it as h itself. The diameter is 1.4 centimeters, so the radius will become 1.4 divided by 2 centimeter, or simply let's write it as 0.7 centimeter. Okay, the total surface area of the remaining solid, total surface area of remaining solid, that will be equal to, okay, now what are the surface that are visible to us? Now very clearly the curved part of the cylinder will be visible outside. Okay, the curved part of the cylinder, so CSA of cylinder, and inside the curved part of the cone will be visible to us, isn't it? So CSA of cone plus, and the base area. Okay, this is still completely closed, right? So the base area of cylinder, so CSA of cylinder is given by the formula 2 pi RH. CSA of cone is pi RL. plus base area of cylinder is pi r square, isn't it? What is common throughout? Pi r is common, so you can write 2h plus L plus R, that is left out. Here, if you observe, the slant height of the cone is not given. Okay, so let's find it. L is equal to square root of h square plus r square. So h is 2.4. So 2.4 the whole square plus r is 0.7 the whole square. Okay. So 2.4 the whole square is 5.6. 0.7 the whole square is 0.49. And if you add it, L will become square root of 6.25, which you can write it in fraction as 625 by 100. Square root of 625 is 25. Square root of 100 is 10. So 25 by 10 is 2.5. So L value is 2.5 centimeter. Okay. So pi value is 22 by 7 and R value is 0.7. 2 into H is 2.4. L is 2.5 plus R is 0.7. Okay. Now here you can cancel 7 ones are 7.1s are. So 22 into 0.1, 2 into 2.4 is 4.8 plus 2.5 plus 0.7. Okay. Now 22 into 0.1, that will become 2.2. 4.8 plus 2.5 will give you 5.3, 7.3. 7.3 plus 0.7 will give you 8. Okay. So this will become 17.6. Okay. If you multiply it, you get 17.6 centimeter square. They've asked you to round it off to the nearest centimeter square. Okay. So the nearest, if you round it off 17.6, if you round it off, it will be approximately equal to 18 centimeter square. So that will be the answer for the 8th question. Okay. Coming to the 9th question, a same type. Okay. A wooden article was made by scooping out hemisphere from each end. As you can see here, in the top also they have scooped out and the bottom also they have scooped out. Okay. Now the height of the cylinder is 10 centimeter. So height is given as 10 centimeter and the radius is given as 3.5 centimeters. Okay. What is the thing that we have to find? We have to find the surface area. Okay. The remaining surface area. So therefore, the required area. Again, the same thing. What is visible to us? Obviously, the CSA of cylinder. The outer part is visible. CSA of cylinder. And inside this surface area of the hemisphere and this surface of the hemisphere. Okay, it is visible. It's like a bowl, isn't it? The inner surface area of the bowl and the inner surface of the bowl is visible. So it is 2 times CSA of hemisphere. Okay. Now let's substitute the formula. CSA of cylinder is given by the formula 2 pi RH and 2 times CSA of hemisphere is 2 pi R square. Now here you can take 2 pi R as common. So we'll be left with H plus 2R. Okay. So 2 as it is, pi is 22 by 7 and R is 3.5. H is 10 plus 2R, 2 into 3.5. Here you can cancel it. 3.5 ones are, 3.5 twos are, and 2 and 2 gets cancelled. We are left with 22 into 10 plus 3.5 into 2 is 7. Okay. 10 plus 7 is 17. So it becomes 22 into 17. So it becomes 34 and 34. 374. Okay. 374 centimeter square. That's the required area. Remember, whenever we find surface area, we have to imagine the surface, imagine the 3D figure and just check out the surface that is visible to us. Only those surface area we are going to find it. So with this, we have completed the first exercise. In the next video, we'll start with the second exercise. Thank you, students.